But it's a single name. What? Just wrestling. You can't do it. No, Johannes just did it. Even Joe's doing it. Did you know, I couldn't write down the notes at all. So I had to watch the video. Just to write it down. I got back from last night. Well, I told her I did it short. Tired. Because all we do is watch shoes. I gave it a 2.
Oh, that wasn't supposed to happen. There it is. That was not as nearly as dramatic as I wanted it to be.
Oh, this thing. Yeah, this is good stuff. You're good stuff. In a few days.
I take that back.
I have to walk down and watch. Wait, so, wait. I could do synthetic and how I can't Yeah.
Do it by long division and synthetic division. Both. Not or, and.
Is maybe 7 or 8.
8. There we go. Campus. Ping pong. Accumulate. Looks like we've got everyone else. Cool. Andy's chocolate mints are the only way that my mom got me to go to social events as a kid. Like, when the adults went back up to the bar to reload, I would be making my rounds and steal those off their tables. Oh, they're good. They're so good.
They're at Walmart, they're cheaper. Like $1.
Yeah. We don't need to tell the stress-eating chocoholic with zero inhibitions that, hey, this is cheap at Walmart. Well, there. Almost. Okay. Nice part about doing it two different ways is you're going to know that you're right. Because you should be getting the same thing both ways. I want to know what you know. No, she knows. Come on, man. Anyone still going? One potato? Okay. Two ways. Option one. Long division. We got to know how to do it because if I don't have a linear factor, this is my only fallback right now. And we say from the top, x cubed divided by x. It's x squared. Take x squared times the stuff. Getting x to the third minus x squared. Then I subtract it. So I change the signs. Calling it 4x squared. Drop it, little warm, minus x. And then repeat the process. See, 4x squared divided by x is 4x. 4x times the stuff is 4x squared minus 4x. But I subtract it, changing the signs. Getting a 3x, drop it, a little warm. Start the process over again, third time, 3x divided by x. And 3 times the stuff is 3x minus 3. So close, swing and a miss. You have that 5 left over. How did we handle that 5 left over? Okay, remainder over divisor is how we've always done it. Like, back in the day, you would say R5. We're talking like 3rd grade. And then they showed you the fraction. Okay, pretty easy. I just put plus 5 over x minus 1 right there. The other way I can do it is synthetically because it is a linear factor. We got all the coefficients, 1, 3, -1, and 2. And we divide by the 0 of that linear factor. So positive 1. Drop my first 1 because it's a little warm. And say 1 by 1 is 1. 1 plus 3 is 4. 1 times 4 is 4. 4 minus 1 is 3. 1 by 3 is 3. 3 plus 2 is 5. And again, I end up with a cubic divided by a linear factor will result in a quadratic. X squared plus 4x plus 3, and that leftover will turn into a remainder. Likey so. So I'm going to say, in both cases, 1 for the quadratic part, 1 for the remainder part. They should be the same in both. 1 for the work, 1 for the work, and then my floater for the facepalm. At the very end, I wrote 5 over x plus 1. Everything worked out just fine, but right here I said minus 3. The little stuff. Okay. Any questions? Nothing? Beans that are cool. Then we'll get that out of here, say, and you go away. You. From the homie work, talk to me, Goose. You've had 70-ish hours. 3 days. Talk to me. Nothing? Good. Good. Then, we're going to hop right back in. If we said that that was good stuff, if we say that we know how to do synthetic division, I'm going to test you. Okay, so right after example 3, where we talked about synthetic division, y'all seem to like it. Most kids do. That got it page, number 21. Do I have a what?
A note packet.
If you don't, that's fine.
I don't know if I have a spare of that. I mean, you can just separate sheet just as long as everything's labeled and organized, and then you just jam it in there when you're done.
It's at my house.
I think I only had enough printed for the class. Normally I got a couple spare, but I don't right now. I changed that to a 3x minus 5 instead of an x minus 5. It's going to get gross. You're going to have to fraction. That's okay. I want you to show me that you can fraction.
So we should use synthetic division?
Yeah.
We can't use the other one?
If you want to do long division, you're still going to have fractions everywhere.
Oh, yeah.
So many times we start to encounter fractions, and because there's two numbers there instead of one, we just kind of give up. I want to see what you can do. Can you handle it if there's fractions on here? It will not be pretty. Negative 70 plus 25 thirds is not a whole number. I have no idea what the numbers are going to come out as, only that they're not going to be great. Hi.
You need a placeholder for the...
Yes, you do. Who already screwed up and forgot their placeholder? There's no x squared term. Make sure you have your 0 as a placeholder. And if you're going to put that in with your notes, make sure that you take the elephant's knot off the side, because that stuff drives me nuts.
Yeah, that's 25, and then you say that, and now you start. But then 10 thirds.
Oh, I forgot a placeholder. Monkey. Sorry.
Wait, is that divisible by 3? All right, because that's negative 210 thirds, 20 thirds, negative 190. Oh, 185 thirds. There we go. So that's 925 ninths. I'm mental mathing, so question mark.
Then minus, oh god. Oh, yikes. So it's going to be negative.
Three by 3 is 9. Negative 925 over 9. Because you have negative 185 thirds and then 5 thirds. 3 by 3 on the denominator.
When we divide by this at the end, would we flip it and just end up multiplying and distribute this, or how would we do that remainder at the end?
This goes to the denominator. Distribute on denominator. Because dividing by this, dividing by fractions, easy as pi.
Okay.
So you would multiply by 1 over that.
And then I distribute the 9?
Yeah. You beat me in the punchline. I was wondering how many would catch that because it's a compound fraction. Yes, sir?
I think I got it, but most people just having thoughts about this. That's what I got from my remainder.
Oof.
Yeah, it's a mess, but
It's way too small right here. Okay, right here you were correct.
so that's what I got when I did that. I took 185 over 9 times negative 5, and I got negative 37.
Oh, because it was over 3. You have it over 9.
Oh, in there?
Oh, wait. Yeah, because I'm going to have to divide all those by 3. Okay, so then over 9. Okay. I don't know about this.
That's what I got.
Okay, so negative 185 is negative 185 over 9. I'm betting negative 185 over 9 times negative 5 is not negative 37 ninths.
Negative
185 over 9 times negative 1/5. That's why. No, you're doing it all right. We just, that part. Hi.
So you can't just type this into your calculator because there's an X, right?
No.
You can't know what the X is. And then,
No, because there's a stored value for X now. It's based off your last calculation.
so you just do it over 3? No, wouldn't you move the 27th? Or would you just literally write it like that? Move a fraction. Negative 907 over 27. Wouldn't you just move the 27 to the bottom and multiply everything on the bottom by it? Right? Because it was a fraction over a fraction.
Dividing by fractions is easy as pi.
Put the second in multiple.
Okay. So, synthetic division. Since I divided by 3 to get my 0, I'm going to need to divide my quotient by 3 as well. Everyone cool to right here? Even if we don't like it, like, we can get there. Okay? So I took a cubic and divided it by a linear. My result should be a quadratic. So I stick an x squared here, an x here, constant here. The question is, what do I do with that remainder? What do we always do with the remainder? Put it over divisor. So if I have a negative 907 over 9 over 3x minus 5, that is a compound fraction. We don't like compound fraction, so turn it into a regular compound, or regular fraction, regular rational expression. Flip the second, multiply. What I'm doing is taking this times 1 over 3x minus 5. So my result is x squared plus 5/3 x minus 185 over 9 minus 907 over 27x minus 45. Distribute the 9 into the denominator. That's some heavy stuff. Honestly, I don't know that I've thrown that at an Algebra 2 class in a couple years. Was it okay? Like, we don't like it, but it was okay. Yeah.
Should we put the 907 over the 27x and over the 45? Would we be able to do that?
No, because it's not 907 divided by this and divided by that. It's 907 divided by the sum. If it's the other way around, if it's 27x minus 45 over 907, they're both divided by 907, and I can split. I can split a numerator over the same denominator. I can't split a denominator over, or a numerator over two different denominators. All thumbs are fingers, not all fingers are thumbs. Okay. So, just wanted to toss that at you to see if you could handle it. Y'all did good. Okay. Synthetic division to solve a problem. The general idea behind this is if I know a expression and if I know another expression, I can divide them the same as I would other numbers. Say, for example, I said I got a box and its total volume is 60 cubic inches. I know that it's 5 inches wide. What is the product of the other two dimensions? I would just take 60 divided by 5, and that gets me my other two, right? 60 divided by 5, because length times width times height makes volume of a box. So if I divide by any one of them, I get the other two that are left. Same thing goes for an expression. We got polynomial is the volume of the box. What are the dimensions of the box? Can you all see down at the bottom? X plus 5 for a width. So if I know that that's the width, I know it's a factor because volume is length times width times height. So if I know the width is x plus 5, I should be able to divide by that and get length times height. So that's exactly what I'm going to do. 17, negative 38, negative 240. And I will divide it by, if I'm doing synthetic division, what goes on the outside? The 0 of it, negative 5. Okay. Drop it a lot and say, negative 5 by 1 is a negative 5. Add them. Negative 5 by 2 is negative 10. Add them. Negative 5 by negative 48, surprise, surprise, 240. Now where this allows me to find the other dimensions is I just found out that x plus 5 times x squared plus 2x minus 48 is how I make the volume of the box. Right? If I take the whole thing divided by the width, the quadratic that's left should be height and length. What can I do with the quadratic now? Well, I don't have to go that far. Factor it. Right? Length times width times height. I need three things. If I need three things and I've already got one of the things, break this into two different things. What factor is a negative 48? Add up to 6. X plus 8, x minus 6. So, how do I know which one's which now? How do I know what's length, width, and height? The width is x plus 5 because that was in my diagram. And it says the length is greater than the height. Well, but that's an x. X is a variable. How do I know that this one's bigger than that one? What if it's a negative number?
It can't be because it's dimension.
There you go. Okay, A, I can't have a negative there because I can't have negative dimensions. B, whether that's a 5 or a 23 or a negative 90 pi, it doesn't matter. If I take thing plus 8 and thing minus 6, if I subtract thing from both sides, you get 8 and negative 6. Which one's bigger? Okay, so I know that this has to be the length, and this has to be the height. Then part B, if the width of the box is 15 inches, what are the other two dimensions? So I said the width, x plus 5, is 15 inches. So what's x? 10. So if x is 10, I plug it in, say the length is 18, and 10 minus 6, the height is 4 inches. It's an application of this. Do not be surprised to see somewhere in your assignment something about geometric descriptors, where you're going to have to divide to find the remaining dimensions. Oh, I still see some scribbling. Okay. I think I once had an entire class get in my quote book for that. It was like, wait, don't erase, period 2. So. Okay. So, same thing, different box. Get it. Same thing, different box.
Because you just added the place that go from nothing to 1A. So just x squared. Right? X squared plus 5. So the x squared plus 5x plus 6. What? Yeah, I was gonna say. Is that right? X squared 5x plus 6. Equals x plus 1. It's 5.
Divide, get quadratic. Got quadratic, factor quadratic. Said something about 6. I don't know what it is about 6. Kids will screw up factoring something with a 6 and a constant all the time. Okay. Once I get to my factored form, 3 different factors. It says polynomial is volume. Gotcha. Width is x plus 1. Gotcha. What are the dimensions of the box? Well, I know that's the width. It doesn't really tell me anything else, right? Unless you got something smarter than me right now, I don't know how to differentiate which one's height and which one's length. I don't know. Is it possible to have a width, a length, and a height like that? Is it possible to have a box that's taller than it is long? Yeah? Okay. Isn't that the new Xbox? Isn't it like a goofy looking tower like that? Yeah, it looks like a little. It looks like one of those 4-can mini fridges that you can plug into your AC outlet in your car. Yeah. So I have no idea. I just know that it's those. That's as far as we can go. Now, if they did anything else, like it is shorter than it is long, like the height is shorter than the length. Okay, now I know. But they didn't give me that, so I can't do it. Okay, next thing. Remainder theorem. Another theorem. Oh, you think this is theorems. Our next section is literally called polynomial root theorems. Like, there's a bunch of stuff about it. We're not going to go through any of the proofs of it. We're just going to use them. Okay? Yeah, you get a lot more of that in Algebra 2, where it's like, blah, 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 famous dead dude, here's a theorem, and we go with it. Now, the further you go in math, you'll come back and actually prove these, but not right now. The remainder theorem, let's go back to what we were just doing. If I do synthetic division and I get a 0 at the end, what does that mean? No remainder. If there's no remainder, what can I say about the divisor? It's a factor of. Like if I were to take 151 and divide it by 7. Well, y'all got a calculator. 151 divided by 7. I get a remainder, right? So that means that 7 is not a factor of 151. But if I bump that up to 154, now it's a factor because there's no remainder. Because my remainder, more specifically, was 0. So riddle me this. If I were to take that same number and I were to put it in for x, okay, if I do synthetic division with 1 and I get a 0 at the end, I know it's a factor. What would happen if I took the original polynomial and put a 1 in for x? I should get 0, right? Like go back here to, I don't know, what's one that we have written down? Like we've got both these, right? All the way back to problem 3, we have both those written down. Okay, then, did either of them go in cleanly? No remainder? This one did? Okay. So if I were to plug in f of 7 and get 7 cubed minus 57 by 7 plus 56, what do I get? Okay, well, that's 350, 399, 343. Yeah, it should be, right? So again, famous dead dude sees that and says, huh, I'm going to try that for something else. This one did not go in cleanly, did it? Like we had a remainder?
Yes, we did.
I want you to try that. What is f of negative 2? Negative 2 cubed minus 14 by negative 2 squared plus 51 by negative 2 minus 54. I'll get 8, 4, 40, 56, right? Minus 56, minus 102, minus 54. That's a negative. Right? Yeah. 110, negative 212, negative 220. What was the remainder when we did synthetic division?
220.
Negative 220. And they start thinking about it and they're like, wait a second. If I get a 0 at the end, that means it was a factor. If it was a factor, then that means that this thing is a 0 of my function. I call it a 0 because when I plug it in, I get y equals 0 because it's an x-intercept. Dude! I don't have to plug stuff in anymore. I can just do synthetic division because whatever my remainder is the same as if I had just plugged it in for x. It has another name. That's what the remainder theorem is, but it's called synthetic substitution. It says if I do synthetic division with a number, my remainder at the end is the exact same as if I had just done plug it in. So if I want to know what P of 3 is, I can take 3 to the 5th minus 2 by 3 to the 3rd minus 3 squared plus 2, getting 32, or no, oh, that's a 3. 3, 5, 81, 243, 243 minus 27, 27, 2, 54. 343 minus 254, so 5, negative 9, negative 191 minus 9 is negative 182 plus 2, negative 180 question mark? I might have lost it. I think I lost it. 182? God, I missed my 2 at the end. Okay. Negative 182, right? Positive? Oh. That's why I was going the wrong direction. Samsonite. Or I could say 1, 0, negative 2, negative 1, 0, 2. I could do synthetic division instead with that 3. And say 3 by 1 is 3, add it. 3 by 3 is 9, add it. 3 by 7 is 21. Add it. 20, 60, 60, 180, 182. It was a faster way to evaluate. Because the remainder, when someone discovered that the remainder of 0 correlated with it being a 0 of the function, and being a 0 means that when I plug this number in, y will equal 0, they connected the 3 dots, they did a little Pepe Sylvia thing, like the murder board behind him, and was like, dude! And then they started trying it with a bunch of other things. There's an actual mathematical proof behind it, and turns out it's always true. Which means I get to save myself time. Because, boy howdy, is that a lot quicker.
Thank you very much.
No, your remainder at the end is the same as if you had plugged it in. See, if I plug a 3 in here for x, I get a 182. When I'm getting a 0 at the end, I'm plugging this number in and I'm dividing by it. I'm evaluating for its 0. And whatever I get at the end, if it happens to be a 0, then I know that this is indeed a factor. The 3 are... Back up a couple of sections when we said that roots are solutions, are zeros, are x-intercepts, lead to linear factors. All 5 of those are talking about the same feature in a different context. Okay? Think about one of your parents. Okay? That might be mom, but someone else calls them wife. Someone else calls them daughter. Someone else calls them Karen. Someone else, like, let's be honest, we're in Spearfish, South Dakota. Okay? Like, everyone's talking about the same person, but in a different context. Someone way smarter than us put 2 and 5 and 6 and 19 together and said, wait a second. This is true all the time. And there's a proof for it. But boy, does it save you time. Do synthetic division, the remainder at the end is the same as plugging it in.
But you can't solve the whole equation.
Oh, no. This is just to evaluate the function. Okay, no. You can't just solve it by throwing a random number in there and saying 5. No. No.
So this is just a faster way to find.
It's a faster way to evaluate. So, can I do the thing now?
Yeah.
Do again. How much faster is it to do synthetic substitution? Choop, 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 choop. Especially if you don't know your cubes and squares and all that other stuff like you're supposed to. Four, 5. 24, so 5, negative 96. It's negative 91. 1 is negative 364, negative 344.
Oh. Got 1.
What?
You said something. I got bored and did this.
Okay.
And what is it? So when when I'm doing the P for this audit, it's just what did it say for P?
These are synthetic division to factor. It's different than P of thing.
Okay. 'Cause I like
If you're, it's going to hurt you in the next section because it's going to take you about 5 times as long to do things.
I kept up.
But if you
I
like
kept
it,
up with synthetic, right?
okay, all right. Yeah, it's always the zero of the thing. We call it the zero of the thing because it's the same as if I had evaluated at that number.
I think it's easy.
Yeah. Oh no, it's not difficult. It's just longer. Because 1, -3, -28, 0, 5, 20. Important to note with these, it says find P of -4. It is telling you to plug in -4. Don't switch the sign. We were switching the sign before because we were finding the zero of the divisor. And we say -4 and 1 is -4, -4, -3 is -7, -4, -7 is 28. 0, 0, 0, 0, 5, -20. So what do I write? What do I even write?
That is correct. Oh, whoa, whoa.
Oh,
We
forgot a
placeholder. Ah, shucks. Zoink, scoops.
I've asked the question 3 times.
That sounds like a lot.
Yes.
So it is.
P of -4 is 0. If I plug a -4 into this function, I will get a 0. Which means -4 is a x-intercept, which means it's a solution, which means it's a root, which means x plus 4 is a linear factor. Okay? And you're going to start to see all the interconnectedness of this. Mathematical murder board. Okay? It is just a faster way to evaluate. How you feel about that? Like, I know we were good with synthetic division. This is just saying, hey, remainder theorem. Zero.
Oh, well, that's all you need to do.
P -4 equals 0.
Well, that's what I'm doing. Usually not the case.
That's all you. Okay. Yeah.
So P of -4 is 0. Because that was my remainder at the end. Yes. No solving. Not yet. We're building all the skills. We're gathering the tools. This is doing all the side quests so you have the cool tools before the main mission. Okay. Let's find some more tools. See, here's the deal. We're about to start solving polynomials that are big. We're going to start doing cubic, quartic, quintic, and probably more. Most of them are going to be in the quartic, quintic area. If I have a polynomial this big, and I can show that something is a 0 of that polynomial by synthetic division, how do I know what numbers to choose? Okay, yeah, right. If I want to, like, I just learned, if I do synthetic division and get a 0 at the end, this is one of my answers. Okay, cool. How do I pick and choose what numbers to put into synthetic division? Insert bunch of famous dead dudes who came along and did a bunch of work for it. Right now, I'm just going to say, look, they did the work, trust it. And it turns out that all of my rational roots y'all remember rationals? Rational is something that can be written as a fraction. All my possible rational roots of ax to the n blah 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 plus c. Okay? Leading term, stuff in the middle, constant at the end. Technically, we're supposed to write this out in sequence notation, but it might break your brain. I take all the factors of C over all the factors of A. So if I want to know what all the possible rational zeros of this quadratic are, I'll take all the factors of 10, 1, negative 1, 2, negative 2, 5, negative 5, 10, negative 10. All the possible ways I could multiply to make a 10, divided by all the possible ways to make a 21. 1, 3, 7, and 21, plus or minus. The catch is writing it out. If I write plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. I have to write it out. All the possible factors of 10 over all the possible factors of 21. I don't like writing plus and minus that many times. Mathematicians are notoriously lazy. So I'm going to write plus or minus this crap. I have already eliminated a bunch of writing. Now I've got all this stuff over 1. Y'all cool with whether it's a positive over a positive over a negative over a positive, or a negative over negative? It's all going to be plus or minus. So, all this junk over 1. 1, 2, 5, and 10. But then, all this junk over 3. But then, all this junk over 7. But then all this junk over 21. Plus or minus all this stuff. There's 24 options up there. Oh wait, no, 32. There are 32 possible, doesn't mean they actually are, 32 possible rational zeros.
There's 16, and you times it by 2.
Plus or minus.
Dude, that's a brownie point.
Definitely not. He told me.
Oh
my god, that was definitely not.
So anyway,
No. He was like 16.
32 possible zeros. Now, 32 things is a lot to guess and check. But 32 things is better than infinite. Like if I just said, hey, solve this. Do synthetic division until you get the thing. How many of you are going to think of negative 5/7? Will you ever just guess that number? Probably not. So what the rational root theorem does is it takes all the infinite powers of the universe and it says, nah, do these 32. Now, guessing and checking 32 things still really sucks. It really, really sucks. We're going to get a bunch of theorems that just keep narrowing it down and narrowing it down and narrowing it down. You ever seen one of those flowcharts for decisions where it's like, did you cause the problem? Yes or no? Is it your fault? Yes or no? Will you be in trouble for it? Yes or no? Did you get caught? Yes or no? And then at the end, it's like, don't worry about it. Okay? We're going to do a bunch of different theorems that help us with that process. So, the first one was quite mean to start with because it had so many factors. We're not going to do that all the time. This one's a little bit easier. If I want to know all the possible rational roots of this, it's going to be plus or minus, I am not writing all those pluses and minuses again, all the factors of 5, well that's 1 and 5, over all the factors of 2. I can't just stop there and leave it like that. I do still have to list them out, but now they're not as ugly. It's plus or minus. This is the rational number set. Just like that's the real number set. Just like the whole number set. The natural number set. The irrational number set. The complex number set we already did.
Those are cool.
Okay. It's just a letter, but it's double vision. Okay. So, I'm going to write all this junk over 1. 1 over 1, 5 over 1. I'm going to write all that junk over 2. Ta-da. So, how many possible rational zeros do I have? 8. Plus or minus. 1, negative 1, 5, negative 5, 1 half, negative 5 halves, 5 halves. Like, I have 8 total options. Now, hey. What are the rational roots? Now, what are the possible rational roots? What are the rational roots? No, those are the possible ones. How do I check if it actually is a rational root? Uh-huh. So I have to go with 2, negative 1, 2, 5. And I got to start guessing and checking until I find the ones that work. What do you want to start with? I got 8 things to check.
1.
Okay. Nope. Didn't work.
Wait. Let's think about this.
1 did not work.
Half.
Try a negative 1. That's a negative 2. So now that's a -3, so that's a +3, so that's a 5, so that's a -5. Cool, one of them worked. What are the rational roots?
Do all of them.
I gotta find them all. Now, here's a bonus though. I just took Okay. I just took a cubic. I divided it by a linear factor. I got a what? If I took a cubic and divided it by a linear, what is left? Quadratic. I know how to deal with quadratics. That's 2x squared minus 3x plus 5. Is this factorable? AC method. 2 times 5 is 10. What factors of a positive 10 add up to a -3 in the middle?
Positive 2, -5.
Well, -5.
Oh, wait, no.
Mutter, mutter, number, wait. Mutter, mutter, number, wait. They don't work, do they?
No.
This is not factorable. If it's not factorable, that means there are no more rational roots. The only rational root was -1. Because the remaining quadratic did not factor. If it doesn't factor, it doesn't have any rational roots. Specifically, -3/4, 75 plus 9.
Right.
7, 5, 8, right? -40, 7, 5, 9. Not only are there no rational roots, there's no more real roots. There's a reason we spent so much time on quadratics. There's a reason that we learned imaginary roots. Now that we know what imaginary numbers are, I can show you there is only one rational root to this, because the other two are imaginary. So what you're doing is find your possible rational roots. Start testing them until you find one that works. Maybe 2 that work, maybe 3 that work. I don't know. As many as you can find. Well, in this case, I ended up with a quadratic. If I can show you that the quadratic is non-factorable, then I know that none of the others will work. Because if it doesn't factor, there's no rational roots. So the goal is to bring it down to a quadratic. Now, there's other things that go along with this, but that's also why we're starting at just cubics. Write out all your possible rational roots. Guess and check your synthetic division until you find one that works. Once you do, you're down to a quadratic. Now deal with the quadratic like we know how. Yeah, make it time.
No, now you have to take all of this and figure out. Oh,
Oh.
6 and 8.
Really big, right? Like,
She knows how to do it.
and came your scissors, punches.
So the top is the second number.
Okay, so
And the bottom is I'll do the negative. I found it.
I don't want to see anything. See this right? Riley.
you gotta do that. 8 minus 2.
What? Watch this. Watch this.
No.
I don't want to be one.
Yeah, 1, 2, 4. The bottom is 2. And the bottom is 1.
Okay. Hopefully we at least got our possible rational roots, right? All the factors of -8 over all the factors of 3 are 1, 2, 4, and 8 over 1 and 3. All that junk over 1 is 1, 2, 4, and 8. All that junk over 3 is 1/3, 2/3, 4/3, 8/3. Then A third of 3 is 1, times 2 is 2. 7 plus 2 is 9. A third of 9 is 3, times 2 is 6. Add them together, 12. A third of 12 is 4, times 2 is 8. I'm going to call that 1, 3, and 4 instead, because divide by 3, divide by 3. Okay. Stage 1, the white stuff. Were you able to get plus or minus 1, 2, 4, 8, 1 third, 2 thirds, 4 thirds, 8 thirds? You got that. Okay. Now, looks like I just got really lucky. I guessed 2 thirds right away. Huh. How am I going to know the difference between you guessed 2 thirds right away versus I gazed into my crystal ball, I communed with the spirits, and the number 2 thirds just spoke to me? I got a feeling about it. I just got a feeling about it, and then I tried it and it worked. And then the quadratic that was left over, there's no factors of 4 that add up to 3. So that means the remaining quadratic isn't factorable, so that means there's no other rational roots. I'm done.
Yes, sir.
If it was a negative 4, but it's not.
Oh, it's the 0. It's set equal to 0.
Right? So, here's the deal. Some of you were guessing and checking and guessing and checking and guessing and checking and guessing and checking. How fair is it that, say, Allison's over here on her like 9th iteration of this? I suppose there were 16 of them. 9th iteration of this before she finally tries 2 thirds. But then Captain Random over there, James, is like, I'm just going to try 2 thirds. And it happens to be the one that worked right away. How is that fair that he just stumbles into it right away and she's over here fighting for 15 minutes? How am I to know the difference between you just guessed really good versus you had a little insider information? Okay. So this is the 21st century. The rational root theorem, Descartes' law of signs, the fundamental theorem of algebra, all of these different things that we're going to talk about, they're used to narrow the possibilities so you don't have to guess and check 100 times. In the 21st century, we can just find the answer, right? But it got there by doing all this stuff that we're doing is in the background. That's in your program. Can I use it to help me and still show the work? Yeah. The guessing. Like, I don't want to guess and check 16 times. But if I can just guess really good the first time and then show you there's a non-factorable quadratic, good enough. Okay? So instead of doing this the hard way, we're just going to say, what do we feel really lucky about? Okay? So, using the rational root theorem. What are the rational roots of the this? Of the this? I'm going to say my possible rational roots are. I feel like I'm reading off like the nominees for an award. And the possible rational roots are.
Johnny?
Okay.
John?
All the factors of 2 over all the factors of 15. Okay? Which means I still have to write it out. My possible rational roots are plus or minus 1 over all this stuff. So, or sorry, all this stuff over 1. There we go. So 1 and 2. All this stuff over 3. All this stuff over 5. All this stuff over 15. Okay. So I have up here 2, 4, 6, 8, 16 different things to guess and check. If I'm going to guess, I'm going to guess really good.
Good idea.
What is that, minus 32? There we go. Minus 32x squared plus 3x plus 2. And I'm going to gaze into my crystal ball. And I'm going to say, you know, I feel really good about 2. I got a feeling about 2. It's my lucky lottery number. Okay? I don't know. I got a feeling about 2. And there's 15, negative 32, 3, 2. And say 2 by 15 is 30, atom. 2 by negative 2 is negative 4, atom. 2 by negative 1 is negative 2, and dude, I got it! I'm so good at this.
Lucky guess, Mr. Sullivan. You're crazy.
I just took a cubic and I divided it by a linear factor. What is my result? A quadratic. If this is a quadratic, can't I factor the quadratic now? If there are more rational roots? Well, nice thing there's a 1 over there. The only way I'm going to make that 1 is by having plus 1 and minus 1. So I just got to try a couple factors of 15. What factors of 15, plus or minus, are going to end up with that negative 2 in the middle? Lies. A 5x and a 3x. Because negative 5x plus 3x is negative 2x in the middle. Or you do the full AC method on it, whatever your jam is. Okay, you 4 goobers up front just need to stop talking. Set each equal to 0 and say x is also negative 1/5 and positive 1/3. And don't forget your kid brother Burger King, 2. Okay. Instead of guessing and checking how many times, I can just guess really good the first time because I'm just really lucky. How am I going to know the difference? Like, honestly, how am I going to know the difference on a quiz between you just guessed 2 and started there versus you knew it was 2, so you started there? Now, you still got to do the work. You still have to back up the work. more importantly, because this process, this is how we're going to get to our imaginary zeros later. And if you don't follow the process, you're never going to find your imaginary zeros. So you still have to have the work to back it up, but you can kind of cheat the work. Okay? So I would like you to find the rational roots of this, guessing really well.
Oh my goodness.
Just want you to feel really lucky about numbers. And for those of you who either struggle with nonverbal communication or are just not paying attention, this is all sarcasm. When I say, what number do you feel lucky about? That does not literally mean, what number do you feel lucky about? Just try it. Because a certain gentleman, a few years ago, as Miss McCreary, my then student teacher, is rolling around the room checking people's work, says, why are you choosing 8? I felt lucky about it. And she turns like this exact... like, just... This kid repeated pre-calc twice. No, after the second D, he just quit. Turns out spending your nights practicing to be on a Rocket League team is not a good way to pass pre-calc. Oh yeah, he's probably good, but no, he's not. He's not pro, not even close. Get good, scrub.
You have to put the negatives? You tell them. No, you have plus or minus.
That's what the plus or minus out front was. Took care of it for you. Yeah, when I say, what number do you feel lucky about, I mean, look at your screen. Yep, that looks like it's a 2. I'm going to try a 2. Okay? It does not literally mean pull a number out of an orifice and hope that it's good. Some people, yeah. When you list your possible rational zeros, you don't repeat things. So for example, 2 over 1 is 2. 6 over 2 is also 2. Or wait, that's 3. You know what I mean? I fixed myself, pal. Okay. When I go to put all this stuff over 2, when I put 6 over 2, I get a 3. I already have 3 on there. Don't write it again. Okay.
Reminder to all students, ASVAB. If the ASVAB test, the interpretation will be right away in the library. Please, if you are a student that has to attend Spartan time, report to your Spartan time teacher and go directly to the library. ASVAB interpretation, block 4 today.
What number y'all feel lucky about?
2.
Okay. Yay! And then that's 2x squared plus 5x plus 3. So it's got to be, oh. Right?
The following students, please come to the office. Greg Kramer.
Because that's 2 and It's not factorable, is it? Yeah, so it'd just be 2. That's it, just 2. Okay. Is it just 2?
It's not just 2.
Factors of 6 add up to 5 are 2 and 3. It splits. Oh yeah, it does split. Okay. Ah, you gotta keep going. Wait. Noise, flustered. Meh.